Hi, I'm Luke Sanita, and my main research focused on the economic value of the goods you can make. Next slide. So let's start with scale because I think it reframes the whole conversation. Concretes, aggregates, and cements together represent somewhere between 300 billion and 1 trillion in annual market opportunity. The CO2 that could be consumed producing those materials runs up around 2.6 gigatons per year. To put that in perspective, I believe that's roughly around 7% of global emissions, absorbed not into the ground, but into products people are actually buying. That distinction matters. This isn't carbon storage where you're hoping that geology holds. The CO2 is chemically bonded into the material itself. It becomes structural, permanent, and the product has full commercial value independent of any carbon credit or subsidy. That's a fundamental difference between this economic model and the economic model others approach. Next slide, please. I want to take a moment on metals because it answers the question that tends to come up early. Is heavy industry actually willing to do this, or is it just PR? The answer, at least in metals, is pretty clear. SSAB rebuilt their entire steelmaking process around green hydrogen, not as a pilot, but as a commercial product line, which with paying customers. Stragella is doing a gigascale with a electrolyzer on site, while Steel Dynamics runs entirely on recycled scrap and renewable power. These aren't just startups making bold claims, they're large industrial companies that have already made the capital commitment. What this tells us is that the customer base for low carbon infrastructure materials is real, funded, and present. The demand extends directly into construction materials, which is where we're focused. Next slide, please. Now, talking about cement is the hard case. About 8% of global emissions, and a meaningful share of that is locked in chemistry. You can switch to renewable energy and still have a significant emissions problem with cements. That's why the industry has moved towards capture, not as a long-term aspiration, but as a near-term operational reality. Looking at Heisenberg Materials is further along. Their Pravik plant in Norway is the world's first full-scale cement capture facility, around 400,000 tons per year. And the CO2 isn't being stored, it's being sold. A food-grade CO2, concrete mineralization, and biofuel research. Their commercial product is called the Evo Zero, and it's already in the market. HoloSim has taken a portfolio approach, multiple capture products across Europe, CO2 being converted into ethanol for shipping or aviation, and e-cycle process locking CO2 into recycled demolition material. Cemex is using concentrated solar heat to convert CO2 and water directly into syngas for sustainable aviation fuel. Completely different technological pathways, but the same destination. So, what's worth noticing? All three of these companies have arrived at the same conclusion independently. Captured CO2 has commercial value. Once an industry internalizes that, the investment follows. Next slide, please. This slide is where the story stops being about potential and starts being about competitive. The carbon neutral aggregates market is already around 1.4 billion, and it has clear leaders. Blue Planet Systems around 30% with synthetic limestone that achieves the highest CO2 capture per ton in the industry. But Nuostark has around 22% and dominates the European market through a HoloSim partnership. Their recharge recycled concrete is currently the fastest growing product in the segment. Now, finally, talking about Carbon Built has scaled successfully in the US masonry and precast department, while MCI Carbon is hitting industrial scale in Australia, converting waste streams into road-based fill. 13% of the market is still fragmented through startups, pilots, university programs, all of the such. At around 1.4 billion, that's still a real number. The thing to take away from this isn't specific market shares. Those will shift. It's that the infrastructure for buying and selling CO2 storing aggregates already exists. Procurement, relationships, pricing benchmarks, performance specifications, the market has developed them. What is still open the question of feedstock? Who can supply the CO2 reliably at scale at a cost that keeps the final product competitive? That's the question we have to answer. Next slide, please. So, where does freight rail come in? Three things make it a strong fit. First, geographically. Rail corridors have heavy industrial facilities, tend to be co-located. That's how they were built. Capturing CO2 along these routes and supplying it to nearby cement and aggregate plants reduces transportation costs in a way that most other capture sources can't. Secondly, consistency. A fixed rail route is a fixed rail route is a fixed emissions point. That predictively makes it far easier to design capture systems, plan logistics, and structure offtake agreements than chasing distributed in or a subpar source. Third, timing. Carbon credits. Low carbon procurement requirements and federal infrastructure funding are all moving into the same direction. The policy environment isn't a tailwind we're hoping for, it's already here. Finally, freight rail is a large, concentrated, hard to abate emissions source sitting along the exact industries that we need to improve. The alignment of geography, infrastructure, and demand is what makes this worth a serious look into our future. Next slide.